So that's good. Can everyone see and hear me okay?
Yep.
Excellent. All right. So let's get started. So the first thing we want to go over today is we are going to be working on a numbers game, and I'm going to basically take you through some of the problems and show you both the thought process behind how we come and arrive to that problem, and then also how to actually solve the problem and code it live. So I guess let's get into it. I'm going to start with a flowchart and just show you exactly. We're really going to make that together. In terms of interaction, don't feel pressure to answer. I might pose some questions to you if you don't know I mean, really feel free to just ask, just to answer. And, really, if you don't know the answer or your answer isn't correct, it's not important. So without further ado, let's get into it. So let me share my screen here. Share screen. Share content. Here we go. And so, okay. Okay, can you guys see my screen here?
Yes.
Yep.
Okay, perfect. So what we want to create is a numbers game. And essentially the way this is going to work is, we have this randomly generated number. And let's call that n. And we're going to prompt the user to determine from to determine basically by guessing that number. And so the way it will work is they'll enter a guess, and then we'll give some feedback as to whether their guess is right on, or if it's too high or too low. Right, and then and we can do that using some of the conditional statements that we learned in lecture, and then and essentially we're doing this very algorithmically, and we're going to do it such that the idea would basically be to eventually arrive at the actual number or something very close to the number, and then to let the user know basically they've been successful. As a restriction, let's just say that n is going to be an integer, because realistically, like dealing with decimals here, like you could go to infinite precision. So let's start with the flowchart. And so I just want to make like a general comment, which is I definitely suggest things like flowcharting or what's called pseudocode. I believe Professor Moore actually talked about that in lecture as well, but definitely suggest that. It can be quite a lot easier to think about how to approach a problem and the actual algorithm without the actual code and the syntax and the errors. So, even if you just figure it out in your mind first, that can be really helpful. So let me start drawing here. I'm just going to turn off my camera because I have to lay down my computer. If you have questions, I don't know if I'll be able to see your hand if you use the raised hand function. So feel free to just if I'm sharing my screen and I don't respond, raise your hand. If I don't, and I don't respond quite quickly, just feel free to interrupt. So let's get into it. And there will be a lot of time at the end to literally 20 to 30 minutes just to answer questions about the assignment, about Jupyter Hub, about Jupyter in general, all of those things. So let's get into that. So for the flowchart, the key idea kind of in programming is that we need to really break down problems into a set of very simple, very rudimentary kind of steps. And those steps are, for the most part, they're very predefined and they're very basic. And so it's kind of hard to understand that basically everything in programming, like these complex websites and computer systems and operating systems that we interact with, are basically a bunch of loops and if statements. But really, it's like computers can do very few things, and programming is all about how you can apply those different things. And those things really are loops, conditionals, like simple evaluations of conditions, of mathematics, And really nothing particularly more complicated than that. I mean, and then it's basically repetition and math. So what we want to do with the flowchart is to see how we can actually develop those concepts. So the first step here, right, would be that we need to basically perhaps to prompt the user and to say like, hey, kind of welcome to the game, right? Because it is a game. So to do that, oh shoot, what did I do? Let's reopen OneNote. And I accidentally closed my OneNote here, guys. Just one sec, OneNote. Okay. You guys can see my screen again?
Yep.
Perfect. So, so for this first step here, let's start off, and I'm just going to make this top down. So we have our introduction, and we want to tell the user welcome the user. And in terms of like actual pseudocode, do you guys remember what how we might be able to like tell the user something? What the function is for that? You can just interrupt it. Sorry, go ahead.
Is it print?
Yeah, exactly. So we're going to print like some welcome message, right? I'm just going to put a ... here for now. And then from there, we need to generate that actual number, right? So we need to find some algorithm, and how exactly we do that, is really just in this case a function, because generating random numbers is actually more difficult in programming than you might think. But basically, we want to generate some random number, and we want to store it to a variable. And so let's just kind of make a variable here. I'm going to put this in red, and we're going to call this n. All right. So we have our variable now. Very easy for you. Okay, and then from there, we're going to need to prompt the user. So prompt user to enter a number. And then we're going to actually go and get that input. And so let's store this input now into a variable again. Pretty much with everything, we can store it into a variable. And we're going to now say user input will be equal to, do you guys remember the function to get user input? Okay, it's the input function, just like that. But I just do want to make a note about this function, like a little bit of a warning here. Don't use it in Jupyter Hub. Your program, you will not pass the test case if you use this. Do not use in your assignments. We will never ask you to use that. So the way that everything works with Jupyter Hub, and I'll briefly explain functions here. So basically, is functions, and so the way functions work is you basically have these function definitions, and you'll see them on every assignment, right? So it'll be like def my function, then this like these something here, and then a colon, and then some code here. Okay, so it'll be like, so for example, square would like to square a number would have the parameter n, right, which is going to be an integer, or it doesn't have to be an integer, I guess, and then it has a return statement and n star 2, right, n to the power of 2. And so we have a few things here. This is just a keyword. Okay. And then this is here is the name of the function. And this is really just, just like you name a variable, there's no difference. And actually functions in Python actually do get stored as variables. And I will make a video soon that actually talks about that in more detail. And then we have this here, and this is the parameter. And so basically this is how the input is actually coming into your program. And so anything that any input that your program needs to take when it's in Jupyter Hub will be through these parameters. And so we'll indicate to you what parameters you'll have available, and then you're going to want to write those into this part of the function here. And the way those basically work is, let's say I do, square of 2. It's equivalent to basically having a line here that says n equals to 2. And then if I do square 4, once again, it would be equivalent to n equals to 4. So basically what it allows us to do is to modularize, kind of make a black box, just like you could do in math, right? Where you have like f of x, where you have the input of 2, and then you have the output of 4, and you just have this square function in the middle. And so whatever number you put here goes to n, and then that gets used to produce the output. And of course, you can have, x, and like you could have, I don't know, like, let me take a good example. Like, I don't know, like plot a point on like some graph, and then the x and y coordinates. And basically the way that would work is like if I did 2, 3, or 4, 5, it would just map exactly to the position. Any questions about functions? Because this is something really important. I just want to get out of the way. Cool. I will take that as a no. If you do have questions, I mean, we're going to cover them in like quite a bit more detail than this, but I think this is a good enough overview that, it should at least eliminate some confusion assignment. So anyway, so now we have this. Now, there is one thing we're going to want to consider here, and that is we always want to think about the data type of our assignment, of our variable. So input, right, it's going to collect a string. And the reason it's going to collect a string is because, well, that's just the way the function works. And, like, you never know what type the user will input. So you want to always collect a string, and they're inputting text anyways. So from there, we're going to need to, in this case, if we want to do any sort of operations with integers, right, this, is not very helpful to us because that's a string. And so even if the user inputs that, we need to convert that to this. And the way we can do that, as you probably recall, is just by using the int function. So if we do int of input, just like that, or we, did int of user input or whatever, like the way kind of, you can just, a lot of these things are interchangeable. Like you can put things inside each other and it causes no problems. So in any case, continuing on, so now that we have our input, and let's just assume in this case that it's an integer now because we did this. So now we have an integer, and what we're going to want to do is evaluate how the input, or maybe we should rename this to guess. I think that's even, it's a better variable name. Order, and it's more descriptive. We want to evaluate how the guess compares to n. So we can say if, so now we're going to have an if statement, right? So we have this if statement here, and the conditional here is if n is greater than, well, I think it's probably cleaner to do it this way. If guess is greater than n, is greater than n, so this is the yes direction, yes. Then we're going to print too high, basically. Too high. And if not, right? So does anyone have an idea of what we should do here?
guess is lower than n.
Close. Except for this right here. And you'll notice that this is a greater than. So what the no condition says is actually not that guess is less than n, but actually that guess is less than or equal to n. And that's important because if guess is equal to n, we don't want to say that it's lower. We want them to win, right? So we're going to need another if statement here, right? So basically this is the else condition, right? And so our other if statement is going to say, okay, well in that case, another if statement that says if guess is equal to n, well then they win, right? So user wins, and we're going to have to print that. And then if not, then you would say too low. And then the only key here is that at each stage we need to do this in a loop because we want to repeat this until the user actually does accomplish that. So what we want to do is then if either of these two cases get achieved, we're going to want to go back to here. This is not a very clean flowchart. My apologies, folks, but I suppose it does the trick. I like doing these things live. I think it is easier to follow that way. But yeah. And so the way we're going to want to do that in programming terms is with a while loop. And so basically what we can do is we can say that while guess is not equal to n, then we're going to want to keep repeating and evaluating and telling the user. So what do you say we put that into code?
I have a question. I was wondering, the loop, shouldn't it go back to prompting the user again?
Yes. Yes, exactly. And that's why I'm having to go back to guess equals input, because input will prompt the user every time. Like that function will actually yeah. So okay. So why don't we get into the actual coding part now? And we can write some code. Oh, someone sent a message. Let's just see here. Yes. Well, no. So okay, like you technically can, but essentially, the auto grader is not using input, and so do not use input. It will fail the test case because in Jupyter Hub, if I remember correctly, what happens when you put input is it actually prompts you as the user to type in a number. And for your own uses or whatever, that might be okay, but that causes problems for the auto grader, which is not a user. And so you don't want to use that in your solutions or anything like that. I would just don't include it in the assignment at all, no matter what. And then you're good. Okay. So yep. So let's share my editor here. This is PyCharm, by the way. This is the ID I choose to use. ID stands for Integrated Development Environment. It's basically a code editor, but kind of a bit more powerful. You don't need to use it if you decide to do any sort of ID outside of just doing things on Jupyter Hub, which I suggest because you may want to do practice problems, and I actually would strongly suggest doing a good number of practice problems. Then this is something I would strongly suggest. PyCharm is very good, and it's free for students. It's actually free in general, and even the ultimate version is free for students. VS Code is also quite good. So take your pick. In any case, so let's create a Python file here, and we're going to call this numbers game, or T1 numbers game. So first thing we're going to want to do in this case, or actually let's start off without even defining a function, because I think here we are going to use the input, even though this is not something you would do in Jupyter Hub. So, one second, I'm just double checking the lesson plan here. Okay, we're good. Yeah. So, let's start off with that welcoming part. So let's say, right? Let's do an exclamation mark. Gotta sound excited. So then we need to go and already start off with deciding what our what we want to use for our like random number. And so there's actually a few ways we can do this. One way is using what's called the math module, and this is generally the way I like to do it. And math, well, maybe it doesn't have it in Python. That's, oh wait, hold on. Oh, that's weird. In that case, Python has a built-in module called the random module. And so what we can do is modules are basically like, you know, there's a lot of built-in functions and variables and constants in the Python programming language, like for math and for things like that. The problem is it would really slow down the program if you had like all of those as variables in every program. And so Python lets you choose what you need by like importing these modules separately. And in a separate video, I'm actually going to briefly go over modules in a bit more specifics. And I'm going to probably post that on YouTube soon enough. But anyway, so what we want to do is we want to use the random module, and we can import a function from there called random integer. So we can do from random, which is the name of the module, import randint. And you can see, by the way, that how my editor is already like suggesting certain things. So that's why I kind of suggest using an editor, even for your assignments. So now this function, we can see it takes two parameters, a and b. And if we click on it, well, actually it's not helpful, but I'm surprised it, oh, maybe it will tell us. Hold on. That's surprising. In any case, I just happen to know. Oh, here's a good example. So if you want, we can go to the documentation here because we want to know what do these do. Okay, and now we understand what these parameters are for. Return a random integer such that a is less or equal to than n such. So basically what we have is we have a range, and it will produce a random integer between a and b inclusive. Right? And that's very useful to know. So now, you know, classic numbers game. Pick between 1 and 100, so here you go. So now we tell the user that they're going to pick between 1 and 100. And so now we can say print a number, well, yeah, guess a number between 1 and 100. Well, actually, let's do it another way. Okay, well, so you'll notice I'm using single quotes. Now, the problem is if I do this, like as an apostrophe, Python is going to think that I'm trying to end the quotation. So the truth is the right way is that in a case where you use a single quote, you should just do the string with a double quote. The other option is you can use this escape character, this backslash before, and it will basically tell Python to ignore that and just treat it like a regular character and not like syntax. But we're going to do it the proper way right now. So okay. So we think of a number between 1 and 100. And so what we want to do now is we want to collect the user to guess. So we're going to say guess equals to, right, our input function. And we're going to say guess which number. Oops, got to do it again because I'm saying I'm. Guess which I'm thinking of. Oh, are you guys texting the chat? No, you're not. Okay, good. I have an extra AM.
You wrote I'm am thinking.
Oh, oops, thank you. Yeah. So guess which number I'm thinking of. And we can even do better. We can, you know, maybe prompt the user to input and like with like a little textual thing so that it's more clear. And one of the ways we can do that, we could also like use that new line character that Professor Moore mentioned in lecture, where basically the way Python works is Python reads a \n, which is one of these escape sequences, just like how you have this \apostrophe. That is how computers actually represent like a line break. So this here is a \n character. Anyways, so we could do this. And what this will do is basically it will prompt us right after this. Like it'll move our cursor here, so we'll type right after this arrows. So then we can also wrap this now in an int. And so this should provide us with an integer. And so now, let's do a classic thing. Let's test it. So what we're going to want to do, we're going to want to make sure, well, so actually, let me do something better. Let me show you a common mistake. So you can see that it's, so this is actually my editor doing this. So let's run this properly. Let's open up the folder here. So we're going to go to show in folder. Hold on, where are you? Why am I failing at this right now? Whatever. Let's just do it. And explore. Here we go. And so if we run this through the actual Python, and I say Python t1 numbers game.py, you can see that it has this nice little pointer. And so now we can say 3. But there's only one issue. I don't actually know if anything really worked in the program. Like, I don't know if it stored those variables because I don't have the result. And this confuses a lot of people. So it's really important that you actually print anything you want to see. Even in Jupyter Hub, although a little bit less so. And one thing people don't know, you can actually just separate them by commas, and Python does all the hard work for you. So now if we try that again, it'll say 50, which would happen to pick, and 3. That's a funny number. Yeah, so it is. So you can see it's quite a random number, and it's printing the second one. And someone took 6 and something. Oh, my apologies, folks. Yeah, that's a good point. So let me make sure I share my whole screen and not just the Explorer. Yeah. Hold on. Okay. You guys should be able to see it now, right? So basically, I was running the actual Python interpreter for my console, and you can see here how I ran the program, but it didn't actually output those numbers there wasn't really any way for me to know. But once we added the print statement here, we can see that it's working. Okay, perfect. So, continuing on then, we're going to move that, and well, actually, let's do better. Let's not delete it. Let's comment it out. Here's a little trick. This is true for Jupyter and like for almost all IDEs. It's really helpful to be able to quickly comment out code, right? Instead of deleting it and then like realizing, oh, shoot, I needed that code later, you can just comment it out. And the way I do that so quickly, from any point on the line, if you press Control/, it will comment out the line. And this can be really useful because you can just comment out a whole section. Or, if, for example, I'm about to write a loop, and if I do like an if statement, if and I write all of this stuff on the main line, and then I, instead of having to like manually go through every line, you can just select the whole thing and press Tab or Shift Tab, and it will adjust the indentation. Some quick tips that will save you some time. Okay, so let's continue with the program. So now what we're going to want to do, and here's where it gets kind of abstract and a little bit hard to follow. So I'm going to try to explain how I come up with how to do this. So we're about to put a while loop here, and we're going to basically say while guess is not equal to n, and then do some code here, which I'm just going to put right now, and I'm just going to, I hate seeing squiggly lines, so let's just do that. Okay, so why am I saying to do a while loop? Well, essentially because I want to think right away about what's the end condition. So when do I actually want to stop prompting the user for some input? And the answer is essentially as soon as the user has guessed correctly, I already want to do something else, meaning something that something different. And so immediately I'm going to think kind of quite forward ahead to the end condition and put that in there. And so now we want to think about, okay, well, so let's assume now that this, well, we know that if this is executing, that guess is either greater to or less than n. And so now all we need to determine is which one of those is the case. So first of all, we know that their guess was not correct. Not a very nice guy, right? So that's the first thing. We have to demean the person who's guessing because they guessed wrong. And what fun would it be if not? Then we need to determine whether they're too high or too low. So that part we can do quite simply. Right? If guess is greater than n, well then, as we discussed in our flowchart, right, we know that they're too high. Now you'll notice here that actually here we don't need to do this because we actually know already that guess is not equal to n. So we can actually just jump right to this assumption. And then that way, in either of these cases, we're going to loop back. And that's, by the way, why I tried to write the loop that way. Because if we know that this is the one case that doesn't loop back, right? Like in our flowchart, we have two endings and both loop back to here and one that doesn't, and only one that doesn't. So what we can do is we can basically say that it should loop until this condition here is met, and this condition is that guess is equal to n. So now we can write and as a side note, of course, someone might suggest that I use an elif here, which would have the same effect in this case. It's really just an unnecessary computation because we've already checked for this case. But if it helps you, both of them are perfectly fine answers.
What is the difference between else and elif usually?
So essentially, elif will. So elif is nice because you could chain it. So let's say, for example. Oh shit! What did I do? There we go. Okay. So essentially, let's say I wanted to just say if guess is greater than n, and then I could do one thing higher, and then I could do elif guess is less, because let's say I didn't have this while loop and I didn't know. I could say, and now I could have another elif, for example, or I could have now an else. And so the difference between them is that else will always execute the second block of code if, only if the first one was false. So if this code didn't execute, this code will necessarily execute. Well, in this case, if neither of these things execute, then this will execute. Whereas elif will only execute if both this did not execute and this condition is true. Does that make sense?
Kind of, yeah.
So, continuing on then. So then the final thing we're going to need to do is, well, we need to ask the user for an input again. You'll notice here that this guess was not in the loop, and I'll explain why that's the case in a second. The answer is essentially because if I do it here, this will not be possible to evaluate. And so we actually, unfortunately in Python, there's no easy construct to do this separately. In other programming languages, there's something called the do while loop. But essentially, we're going to manually need to execute this first step so that guess is defined. And then we're going to want to modify that variable at the end of the loop so that on the next iteration of the loop, we have a new guess. And finally, know that this loop, right? So what will happen is this will update when the user now makes their second guess. It will go back to here and it will evaluate this condition. And if that guess is now equal to n, then this condition will be false. And so we're going to jump right out of this while loop here, all the way to here. And so now we can write you win. So let's execute it. Oh, did someone type? No, guess not. Excellent. So let's do this again. So who wants to guess a number? Someone guess a number. Okay, me. 50. Okay, 2 no. Oh, well, someone else gets the number. 35. Sure, well, we can guess that one too. I mean, it's not a very good guess now that we know 50, but that's not a big deal. Okay, let's try 75. Too low still. Okay, 90. Too high. Okay, 80. Okay, so it's like, wow. I mean, that's good at least. We know that it's like quite right on there. Bruh. There we go, 78. Okay. So now we know it's 78, and we can see that this program works properly. Now, one thing I want to just point out is if we wanted to, we could actually put all of this in a function. And so we could just write like, and like that. And so in terms of, but let's actually execute this code, right? Does anyone guess what's going to happen when I press run? What it's going to output? Take a guess if you know even better. So here's the hint. Absolutely nothing. And let's see why. So we press run. Actually, it's better if I do it with this. Nothing. The program runs, no errors, everything like that. And the reason why is because the only code that's actually executing here is this import statement, which does nothing. And then this line right here. I mean, all of it's executing, but really, this code is because it's wrapped in a function, it's actually just the function definition. And what I mean by that is that the way functions work, right, is it's like this repeatable code. And so unless you actually call the function, it will not execute. And this is a common mistake people make. Unless you do this, this will not do anything. And so now that we have this done, oops, and we call this. All right, let me just run it the same way I've been running it before. Now we have the expected behavior once again. And we can do which is exactly what we want. And there's some other fun things we could do in here if we wanted to. For example, if we wanted to like, count the number of guesses it takes someone. So we could say count equals, or like guesses. And so we can say guesses equals 1 now. And so on each iteration of the loop now, after they guess, we're going to say guess plus equals 1. So we're going to increment guess. And if anyone doesn't know, though I'm quite sure it was mentioned in lecture, but this is just equivalent to, oops, don't get the variable names confused. It's the same code, just looks a little nicer. And so at the end, we can say some guesses. And one thing I want to quickly show is something called f strings. And this will save you a bit of time. There's a couple of ways that you can insert code. One way is, like Professor Moore mentioned, you can basically do that, and then you could say dot format. That's one very good way. Another way, you could literally just do it manually. So you could go. But this is not an ideal way, and like it looks ugly, and you have lots of spaces and stuff. And then the other way, which is the newest way, and I would definitely suggest it, is called f string. So if you actually put an f right before this quotation, outside of it, but right before it, it will let you do this. And you'll notice now that this is actually a code environment. And like my editor is saying, hey, you can put code here. And so I can put this in right here. And now it will do that. So if we want to, we can run that one more time. And you'll see that it's now keeping track of the number of guesses. So 50, 25, 35, 30. And that took you 7. Oops, and I need the word guesses. There you go. Okay. I will now open the floor to any questions about anything at all. Jupyter, like completing and like practice assignments, anything like that. Happy to answer questions.
When you were talking about random numbers, you used the term. Sorry, I can't hear myself.
Yeah, go ahead. I can hear you well though.
Okay. Yeah, like you used the term module, and I was wondering, is that a synonym for library?
Basically, yeah. Not technically. So technically speaking, in Python, a library refers to something which is actually, well, usually is published or like is something that you would import from somebody else. Whereas module actually can also refer to, like, if you like literally if you put a specific file in this folder called this file here, it technically, this whole folder becomes a module. So like the way modules work in Python is a bit weird, but essentially, yes, they're very similar or synonymous.
Okay, thanks.
So if you have so with any string, it doesn't actually matter that it's a print. With any string in general, if you put this f before it, it becomes what's called an f string, and it allows you to do what's called like interpolation, basically to put in the middle this thing. And you'll notice here, like, my editor also has this as a different color because this is a variable. And like I could also do like guesses times 10 or any Python expression that I want to put in here. It will just evaluate what's within the braces as a Python expression.
Could you have generated the random number and then said welcome to the numbers game?
Yes, absolutely.
Okay.
The idea is it really doesn't actually matter. I could have done this right here. In the case, right, like basically you'll just notice as soon as I go move it, it comes red. As long as I define the variable before I use it elsewhere, it's no problem. So because I'm not printing it or using it in any fashion, it absolutely doesn't matter at what position I decide to define this number. It just doesn't make a huge amount of sense because this is technically a lie, but the user does know that. Yeah, one thing I'll say, and if you guys have other questions, feel free. Like I said, you'll notice that I use a certain like something. I just want to make a comment about like code style and variable names. And in the video that I'll probably release today or tomorrow, I will go into much more depth about this. But Python has quite a specific style convention, and I suggest that you try to be as consistent with the style convention as possible. It's quite a good convention, in my opinion. It leads to some clean code. If you also use line breaks, try to make an emphasis on how you organize your code in a way that is actually clean. I think it will help you to solve problems. Like it's screaming, Pep8 is the name of that. It's screaming at me saying, hey, you need to have a new line at the end of the file. That's not a big deal in my opinion, but there are some nice, really, really useful things. One of them is snake case, which I'm actually not a fan of, but for Python, I am a fan of. And it's basically how you just choose to name your variable. So there's like some different ones. I think Professor Moore likes camel case and upper camel case. But I would strongly suggest that you use like snake case, and basically snake case is basically you try to shorten things, and anytime that you have multiple words, you would put a space, an underscore between them as like kind of like a space. And then you basically never will have uppercase variables. And that's the Python convention. I think like objectively, it's probably better than Professor Moore's opinion in this case because that's the Python convention. And it's like, so the biggest thing I think with code style is be consistent. Whatever you do, always do the same thing. It makes everything easier. And it's harder to be consistent with something like camel case or upper camel case because that's not what the Python language uses. So any functions that you're using from the Python language or any modules or libraries that you import will all use snake case. And so that's why I would suggest that. And then also use descriptive variable names, right? These are very descriptive names. You know from the name of the variable what it is. N is probably the worst one here, but generally when there's a number that has no meaning, I think that's fine. You could also like rename it to like random number, and that would maybe be better. But it will help you if you name variables instead of just like I see a lot of like M and just like P and just like random letters, and that's just not helpful. Are there any questions about the assignment? Shouldn't the guesses plot? Not quite sure what you mean. So the reason why I've done it this way is essentially this guesses is always getting set after the user makes a guess. And the idea here is that this plus equals to 1 is just increasing the already existing guesses by 1. Right? And so the way variables work in Python, as Professor Moore briefly covered in class, a variable, once you define it, exists within the whole variable. And so you can modify it after, and then it will basically continue to change. And so the idea here is that no matter what, because we've defined it here, even if this while condition is right, it's possible that the user will guess correctly on the very first try. And so it's important that we already have guesses defined so that it will not be undefined here. If it's undefined here, we'll have an error. And you'll notice actually, well, yeah, if I didn't do this, I'll probably be an error here. Well, actually, that's true. But even if I did like this, it would still say here, my editor will say it might be a reference before assignment, because there's a possibility that this will be true on the first go, and then it will never be defined. Okay, I do have to let you go, but I want to go over what we're going to be doing tomorrow briefly. So tomorrow is actually going to be mostly practice problems. So we're going to be going through some coding back problems, and I can actually post in the Teams channel a list of exactly which ones. I just have to pull up exactly the lesson plan, or like which problems Professor Moore wants me to go over. Yeah, so we're going to spend like 30 to 40 minutes doing some of those problems on coding bat. And so what I would suggest is there's a few specific ones that I'm been asked to go over, and then I can also go over really what. Oops, I did not mean to do that. There we go. That was weird. And then I also will go over anything you want me to go over. So if you see any problems that are not those, let me know. I suggest that if you have time tonight, it would be a smart idea to go and practice some problems. You might find them challenging, and that's the point. Come with questions, interrupt me, like put me on the spot tomorrow, and I will do everything I can to kind of help you understand in a better way exactly what's going on. Yeah, like we're just going to do a whole bunch of problems tomorrow. And if you have any other questions or you have issues with Jupyter, make sure you can get into Jupyter today. That way, if you have problems, you can message me tomorrow. I also have office hours on Friday from 4 to 5, so you can come then, or you can just message me like on email or Discord, anything like that. You're all good to go. If you have questions, I'll probably stick around for a few more minutes, and I'm happy to answer any questions or concerns that you guys have. So thanks for coming to tutorial today. Bye-bye.
Where are all the office hours posted?
So Mark just posted them actually in the office hours channel here.
Oh, okay.
It's the way we've set it up is that there's basically an office hour every day except for Monday. Professor Moore has not decided yet what time he wants to host the hours, but it's going to be on Thursday morning for sure. I mean, he has always done that. And then the rest of us just always have from 4 to 5.
Okay, perfect.
But honestly, I think all the TAs are pretty approachable. So if you have questions, like you don't need to wait for office hour, especially if it's like you're just in the middle of something, just message us, honestly.
Right. And then is it okay if I ask a few questions?
Yeah, absolutely. Go ahead. I've time. So just
okay,
ask.
Sure. So I just wanted to confirm, it's totally possible to be in quote unquote be in multiple libraries at once, right?
What do you mean by to import?
Sorry, like I meant that you can import two libraries and use things from
Yes.
both libraries in one piece of code.
Yes, like even like for work right now, I'm doing some stuff in Python for like a lab, and you have to see it. Like there's probably like
like 500.
20 to 30 lines at least of imports, and
Yeah.
there are some programs which will like have 50, 100 lines. Like so that's absolutely possible. You just shouldn't import too much that you don't need.
Right.
Because theoretically it slows down performance. That's true to a very limited extent. Like programming languages generally are fast. I mean, Python is slow compared to other languages, but it's still very fast. And so unless we're talking about thousands of things, it's no issue.
Right. And the reason that libraries need to be imported is that because, sorry, I guess I'm just a bit like, why?
So I'm going to show you guys a bit of Python internals here. And this is, you don't need to know how to do this at all. But so if we open the interpreter, there's a function here. And this basically tells us all of the functions that exist in what's called the global namespace. And so basically what this is this is all the things that we can.
Do you need to be screen sharing right now?
Oh, yes, thank you. Why do I keep forgetting? This is annoying. Okay, I apologize. Here, let me. Now you guys see it again, right? So This is Python interpreter. So if I go to Python here, we have this function here, and this is a built-in function from Python called the globals function. It basically shows everything that's what's called in the global namespace. And so these are, and I know it's not very easy to read, it's not important, basically all of the things that are built in right off the bat that are available to you. And so like, for example, if you do main name here, it will print out main, and it's a variable, it's a string. And there's actually quite an important usage for that, but I'm not going to go into that because that's quite advanced actually. But if, let's say I import math. Now, if we see globals here, there's this new math module, right? But if I do this now, or from math, import star, and star will import everything. See? So now all of these functions, right, like the cosine function, or, like, right, now we can call cos. I mean, it'll want a number, but like cos1, right, or cos math.pi will probably be pi is probably imported, so it's probably that, right? There you go. And so you can see how it can get big quickly. But now if I like, I don't know, probably this is going to be an error, yeah. But like if I, now I do like from random import, and now I do like, let me think what else. Or like from, these are all built-in libraries, like, right? And so and Python has probably at least like, I'm just going off memory here. Now if we try this again, right? So that's what I'm trying to say is, if the programming language has to basically like loop through and look through all your variables,
right.
And you import everything like that, it will be slower. And that's the reason why you have to import things, but you should feel very comfortable to import whatever you need.
Yeah.
If you really care, what you can do, right, you could say let me do it this way. You can say, like if you only need a specific thing, you could say, let's say, from math, import cos.
Right.
Or, right. And that will only give you now sine and cos.
But like for like our purposes, it doesn't really matter. That's more like if you're actually.
It's a bit cleaner. It's a bit cleaner in my opinion, but really it doesn't matter. I mean, one of the things I think often I will just import math itself. But oops, I have to do this. And then, now you would just do math.cos or math.sine.
Okay.
Does that help?
Yeah, and then you said that there is a difference between. So wait, so you use the term built-in libraries. So are there non-built-in libraries?
Yes. So, and actually there's thousands of them. Python is famous for this. I mean, Python and JavaScript usually here. So this is what Mark may have talked about. I mean, I don't know if you installed a local Jupyter installation yet, but if you actually go here, pip is actually the Python package manager. And so you can install these packages, which are basically libraries. And so a good example of that is actually Jupyter Notebook. And so the way that you can import, let's say, like Jupyter Notebook is one example of a package. Another really common example, which actually is available on Jupyter Hub, if you in theory wanted to use it, is like NumPy. There's thousands of them. So yes.
Okay.
But I don't suggest using those at all. Hi, Sarth. How you doing?
Also, if anyone else wants to ask a question, like, feel free. Okay, if no one else has a question, I just wanted to confirm that I'm just going to type it into the chat. I think that's easier than describing it.
Sure, no problem.
If I had something like that, I'm not sure if the syntax is very sorry, but if I had something like that, would it return the number 2?
No. Wait. Yes, absolutely.
Okay.
I didn't read the int part. Yes, yes. It so, the way the int function works basically is, it's kind of like a round function, except that technically speaking, it doesn't round. So basically,
it just drops the decimals.
Yeah, exactly. So like
Okay.
this.
So even if it was like 1.9999, it would just turn
Correct.
1 because it just cuts off. Okay.
Correct. You lose all of decimal precision. The only exception might be, and I don't think this is even true in Python, if you go enough, what actually happens is Python, you go beyond the level of precision where basically it only stores so much precision. And so if you go past the end of the precision and there's no 8, well, then it just figures that it's a 9, and so it's equivalent to 4. But yes. Except for that, like very rare edge case, yes, it just will go down. Yeah, if you have any other questions, go right ahead. If not, we can wrap up.
I might just go to office hours. Yeah.
Sure, no problem.
Yeah, thank you.
In that case, thanks for coming, everyone. Thanks for all your questions. And I will wrap up and post the recording.
Thank you. Bye.
See you guys.